Hello, and welcome to my instructional design plan presentation. My name is Sandy Coleman. I am a K-5 computer special teacher at Milton Elementary School. My plan is designed to address an instructional problem for Milton Elementary's fifth grade. There are 3 fifth grade homerooms of mixed ability students with an average class size of 26. Each class comes once a week to Computer Special for 45 minutes. The instructional goal is students will be able to create a program that's efficient and scalable by identifying when a variable is needed for abstraction and by coding a project that uses variables to store and modify data that includes variables, sequences, events, loops, and conditionals. To develop the instructional goal, a need assessment was completed along with a review of the CSTA K-12 computer science standards. The need assessment confirmed that the fifth grade students struggled with conceptual understanding of variables and how to use them and apply them in their own coding projects. Students who are unable to use variables correctly will not be able to write efficient and scalable programs, but it will also hinder their development of computational thinking. In this technology-driven world that we live in now, it's more important than ever for students to develop robust computational thinking skills. Not only is computational thinking skills needed to be successful in computer science, but it's also applicable across all disciplines. Here's my goal analysis diagram. I use this to identify the entry-level skills my students needed to start instruction. The subordinate learning objectives are prioritized to build upon each other and to ultimately meet the CSTA K-12 computer science standards, as well as meeting the overall instructional goal. In learning all of this, students will further develop their computational thinking by becoming proficient in pattern recognition, algorithm design, decomposing problems, and finally abstraction. To appeal to my diverse fifth grade students, several instructional strategies will be utilized in the plan, such as pair programming and debug it challenges. However, I would like to highlight the use of unplugged computer science activities as an instructional strategy. Unplugged computer science started as a set of learning activities designed to explain computer science concepts without using a computer. It has evolved and is now considered to be a best practice and a research-based pedagogy for teaching computer science and computational thinking. Unplugged CS is fun, engaging, and often kinesthetic opportunity for students to understand complicated and sometimes very abstract concepts in an approachable, real-world way. Not only do these activities make CS more accessible for all students, but are also particularly useful for building and maintaining a collaborative classroom environment. On the right, I have included some additional resources for teachers who may be interested in exploring using unplugged computer science activities with their students to integrate computational thinking into their classroom. In the first lesson of the unit, the variable poem unplug activity from code.org is used to introduce variables. I would like to demonstrate this activating strategy with you using a very special class of code.org celebrity computer science advocates. So let's say I want to write a poem for this special class. So here goes. My first student, Stefan. My student, Stefan, standing proud is a fine example for the crowd. But Stefan's not my only student. I have another student. My student, Shakira, standing proud is a fine example for the crowd. I still have another student. My student, Serena, standing proud is a fine example for the crowd. Now, I could continue on with this, but by now I'm sure this is getting a little bit boring, and as it would for my students. And this would take a long time. Depending on how big my class is, it could be really long. So that's when a discussion would start. What could I do to make this quicker? Right. And by this point, I'm hoping that my students will notice that each and every poem is exactly the same, except for the names are different. So each student's name is a different name. Is there a way that I could use this poem almost like a template and have a placeholder? So instead of writing every single sentence, right, I could have a placeholder and I would want to name that placeholder something meaningful. So I would name it probably first names, I think, since that's what we're dealing with and that's what we're switching out are first names. So that would make this process go a lot faster. Instead of writing and erasing every sentence, I would just write the sentence once and then fill it in with my students' names. So this is a solution to our problem. And it was done by taking out the details, by using a variable. Same thing programmers do when they're writing games. If they had to write scripts for every time there was a score, for instance, or each player, it wouldn't be practical. That's where the use of variables come in. And that's something that we would be discussing as a class. So that's the idea behind this activity. This instructional plan includes assessment opportunities for both the teacher and the students. Formative assessments are to take place at the beginning, throughout, and the end of each lesson. These assessments include teacher observation of student discussions and performance of activities such as the debug it challenges, for example. There's also opportunities for student reflection in the design journals. This information will be used to revise the instruction as it is delivered. The unit ends with a performance task that will be used as a summative assessment. To determine if the plan is successful, I will be evaluating the students' performance task projects. The rubric's criteria for the performance task is aligned to the learning objectives set out in the plan. It will determine if students are demonstrating mastery. Additionally, the performance task projects will be analyzed with Dr. Scratch. These scores will be compared to the pre-instruction Dr. Scratch scores with a particular focus on the abstraction and data competencies. Also, student reflection will be a vital component to consider. The assessment of the plan will include student engagement and motivation and pace of instruction. These results will indicate the effectiveness of the instructional plan and will be used to guide all revisions. The process of creating my own instructional plan using the systematic approach of instructional design has been a valuable learning experience. When I reflect upon how I create my lessons, teach, and assess students, I believe I've been taking a systematic approach. However, by following a procedural framework in developing this plan, I have gained a greater awareness of the value of keeping a tight focus on the learning goals. I have a greater understanding of the importance that all instructional materials and strategies need to be chosen to support the learning objectives to maximize students' learning outcomes. Also, the systematic approach requires the designer to evaluate the learner's needs when creating goals, therefore minimizing the time allocated to less relevant, unnecessary, or ineffective instruction. Although I may not always be able to accomplish each step in designing my instruction, I plan to adopt many of the steps. For example, one tool that I found extremely helpful was the goal analyst diagram. I referenced it numerous times when I was writing this plan. The process of creating this diagram forced me to look closely at the learning objectives and the steps that it would take to reach these objectives. By identifying subordinate and entry-level skills, I will be more likely to design effective and efficient instruction. Finally, by remembering to consider all components of instruction and continuously assessing and revising, I will set the stage for successful learning outcomes for all of my students. Here are the references to the sources that I used in this presentation.